Hi everyone, so today we're going to go over interest equations. My setup right now for my video is really great, so just bear with me. So interest, we're talking about like interest in a bank. So interest is just the amount of money that you gain on either an investment or a loan. In other words, it is the basically the amount extra on an investment that you're getting or the amount of extra on a loan that you'll have to pay. It also could be the amount of money that a person receives from a bank for placing money in a savings account. So if you open a savings account at a bank, they will give you money for opening that account. Usually it's like pennies, but you're earning interest. Compound interest, which are the equations that you're going to see in this class, are interest that is given multiple times per year. So instead of just like getting interest one time every year, you're getting interest multiple times. So maybe you'll get interest every day, maybe it's just every month, maybe it's every week. It could be all the time, like you could just constantly, continuously be getting interest. And we'll talk about two different options. The first one being just regular compound interest. So here are compound interest formulas. Regular compound interest, so this formula A equals P times 1 plus R over N, all raised to the N times T. A is the amount of money in the account after earning the interest. So I'm going to put that right here. Amount of money in the account after getting the interest. But R is your rate. So rates will be percentages that are converted to a decimal. To do that, you're going to divide your percent by 100. So if you need to write that down, you can. That's how you convert to a decimal. So like 9% would be 0.09. P in this equation is the amount that you start with. The P stands for principal. It's actually spelled the same way as like the principal in a school. And that's your starting amount. So your initial amount. Whereas the A is the ending amount in the account. T is the time. And the only thing extra in this formula is N. So N is the number of times that you're earning interest. So I wrote the number of times that you are earning interest each year. So N could be 1. If N is 1, then in the question it'll say that you're earning interest annually. That's 1 time per year. If N is 2, in the question it might say you're earning interest semi-annually. Another word they could use is quarterly. So they're splitting the year into quarters, and that would make N be 4. You oftentimes also could earn interest monthly, and that would make N equal to 12 since there are 12 months in a year. And finally, another one we see often is weekly. So N is 52. It doesn't have to be one of these 5 numbers. It could be something else, like daily would be 365. It really could be anything. All right, so here's how that formula works. So let's just focus on the A equals P times 1 plus R over N to the N times T. So right here. So our example of regular compound interest, we have $1,200 is invested. So that's our starting amount. So that would be our P. And it's invested at 12% interest. So 12% is going to be our rate. But our 12 needs to be divided by 100. And that's going to be 0.12. So we'll put 0.12 in our equation. And then it says compounded quarterly. So this is where those n values come into play. So quarterly means 4, so n is 4. How much money is in the account? So we don't know what A is after 12.5 years with no deposits or withdrawals. So the only extra info we have is 12.5 years, and that's our time. So plugging all of this in, we'll have A equals, so first we have P. P is our starting amount, which is 1,200. Then we have 1. So this 1 is going to be in every equation. Really what that means is that's also a rate. It's 1, which represents 100%. So it's like saying, all right, we're going to take all of the money that you invested and then we're going to add on a little bit more depending on what the rate is. So the 1 is just representing 100%. And then we have our rate that we're gaining. So that's why we have a plus here, because we're gaining money. So the R is 0.12. And our N is 4. And then in the exponent, it's N times T. So N is 4. And T is 12.5. So to figure out our final answer for this, we're just going to throw all of this into the calculator. If you want to be fancy, you can, but you really don't have to be fancy with your fraction. So you can just do like 0.12 divided by 4 raised to the 4 times 12.5. If you really want to be fancy, you can use alpha y equals, oops. Let me put the 1 in first. But if you really want to be fancy, you can do alpha y equals and enter, and that'll let your 0.12 be a fraction, but like it really doesn't make a difference. I think the first way is faster. You get the same answer either way. So $5,260, and usually we round these if it's not noted to the cents. So cents are 2 decimals, so that would be 0.69. All right, so that's regular compound interest. The other equation we have is continuous compound interest. So this equation actually stems from this equation. It means that you're gaining interest continually, all the time. You're always gaining interest. So the reason why this equation turns into this equation, remember that E is a constant. So it's just a number. E is approximately 2.718. In this equation, we're just going to use E, but remember that that's really what E is representing. So how does this equation turn into this one? So I'm going to show you something really quick that kind of approximates this for you. So if we look at our original equation, and instead of putting numbers like 1200 and 0.12 and 4 and everything like that, I'm going to boil this down to like the most basic version of this that you could possibly see. And that version is me putting ones in for everything. So, like I said, my setup is really great. So let me show you my computer. We have, if I plug in 1 in that equation for everything, I just get an answer of 2. Now, in all the rest of the examples, I'm going to change what the n is. And the n in that equation appears on the bottom of the fraction and in the exponent. So if I change the n to 2, like I'm compounding semi-annually, then my answer is 2.25. If I start with $1 and I compound it quarterly, I come out with $2.44, like $2.44. If I start with $1 and I compound it monthly, then I come out with 2.61, so $2.61. As I work my way down and I change my ends to numbers that are bigger and bigger, so if I compound weekly, if I put in 52, since there are 52 weeks in a year, I get $2.69. If I compound daily, since there are 365 days in a year, I get $2.71. That's getting really close. I threw in 8,760 because that's how many hours there are in a year. So if I compound hourly for the whole year, I get 2.718. And remember, E, which I wrote right here, is about 2.718. So if I take the most basic example and put ones everywhere, as I just change the n to bigger and bigger numbers, I get closer and closer to E. So when we want to compound continuously, that's why there's an E in this equation. So A equals PE to the RT. So the P is still the principal amount. The E, you're just going to use the E button on your calculator. R is still your rate as a decimal, and T is your time. So down here, if you see the word continuously, then you're going to be using that equation. So Jacob invests $8,634 in a saving account. So that's his P, that's his initial amount, with a fixed annual interest rate of 2.67%. So you're like, okay, R is 2.67, but we're going to divide that by 100, and we'll get 0.0267. And then we see the word continuously. This is the big word that tells us that we're using the E equation. What will the account balance be after 6 years? So that's our time. So on this one, I'm going to do A equals 8634 E, and then I have my rate times my time. So my rate is 0.0267, and my time is 6 years. Throwing that into my calculator, I've got 8634. And then I'm going to use E, so I can either do second and then the division sign, that'll give me E. Or since I know I'm going to raise it to something, I like to use this E a lot of the time. So I'll do second and then ln because it'll already give me an exponent. And then I have 0.0267 times 6. So I've got $10,134.12. So this continuous equation is not only used for continuous interest, it can be used for anything that is happening continuously. So one thing that people always say is happening continuously is population growth. So that would use this formula. If things are decaying really quick, that also uses this formula. But for decay, the R value is negative. So if something's like decaying very quickly, the R value would be negative. This formula is pretty much strictly used for compound interest. You really don't see any other applications of it. So it's just this one that you need to be on the lookout. So if they say the word continuously, even if it's not a loan or an interest question, you can still use this formula. All right, so we're going to look at a few examples. So on page 11, number 1 and number 2. So number 1 says the decay constant of radium is negative 0.0004 per year. How many grams will remain of a 50-gram sample after 20 years? Since change takes place continuously, use the appropriate formula. So here's an example where you see continuously. So you're like, all right, I'm going to use this PERT. Some people call this a PERT formula since it looks like the word PERT. All right. The nice thing about this question is they gave us this as a decimal already. We don't have to convert it. So our R is going to be negative 0.0004. That'll be our R. We need our T and we need our P. So how much will remain of a 50-gram sample? So that means we're starting with 50 grams. And after 20 years, that's our time. You don't have to write it down on the side like I do. You can just plug it right in. So P is 50, E I'm just going to keep, R is negative 0.0004, and T is 20 years. So throwing that into my calculator, I've got 50, and then E negative 0.0004 times 20. So 49.6. So since this one isn't money, I'm just going to keep it as 49.6 grams. So it really didn't decay that much over 20 years because this rate is really like 0.04%. It's like something super small. All right, let's check out number 2. In number 2, it says, in 2000, $320 was deposited in an account that pays 7% interest semi-annually. So when you see some word like that, you're thinking, oh, like compound interest. With no withdrawals or deposits, how much was in the account in 2005? So let's start at the beginning. In 2000, all right, we don't know what that means yet, $320 was deposited. So that's my P. In an account that pays 7% interest. So 7%, that's my rate. And we're going to divide that by 100 to get 0.07. Semi-annually, which I already underlined, is telling me what my N value is. Semi-annually means twice a year, so that means N is 2. So the formula that I'm using is this one. Since it doesn't say continuously, I must be using this one. I have P, I have R, I have N, so the last thing I'm looking for is T. T is our time. So we started in 2000 and we're ending in 2005. So that means our T is going to be 5 for 5 years. So plugging all these numbers in, I've got 320, 1 plus 0.07 over N, which is 2, raised to the 2 times 5. Throw that into my calculator. 320, 1 plus 0.07 divided by 2 raised to the 2 times 5. So we've got $451.39. Right. So now you have another example of each one. The top example being one that's not an interest problem, but can still be used using that P equals R, A equals PERT formula. Okay. The last ones I want to go over are numbers 6 and 7. They are a little bit different in terms of solving. So let's look at number 6. Number 6 says, how much money would you need to deposit today at 5% annual interest compounded monthly to have $20,000 in the account after 9 years? So let's look at what they're giving us. first it says we see this compounded monthly. So that should be telling us that this is the formula we need to use. So let's see what we can fill in. So we know our first number here is 5%, so that would be our rate. So our rate is 5, dividing that by 100 gives us 0.05. Compounded monthly is telling us that n is 12. And we want to have $20,000 in our account after 5 years. So this is the ending amount. So which one of these two things is the ending amount? That's going to be A. So our A is 20,000. And then it tells us 9 years. So that's our time. So the thing that's missing is P. We don't know how much money we had initially. So how much money would you need to deposit today? So we don't know how much we're depositing. So P is what we're going to solve for. So A is 20,000. P we don't know. R is 0.05. N is 12. And then 12 times 9 will be in our exponent. So the nice thing about this problem is that all this garbage after P is just a number. We can figure out what number that is on our calculator. So that's what I'm going to do first. I'm going to evaluate just this 1 plus whatever. So I'll go to my calculator, I'll do parentheses. Let me just turn the brightness down a little. Okay. So we'll do parentheses 1 plus, and then I have 0.05 divided by 12 raised to the 12 times 9. So this is a big long decimal. I'm going to write the whole thing down. So 20,000 equals P times 1.5668466649. Okay, I need to get P by itself. So P is being multiplied by this random number. If something is being multiplied by a number, how would I move this number over to the other side? Well, I'm going to have to divide. So I'm going to divide both sides by 1.56684, whatever. Those will cancel, and I'm going to do the same thing on the other side. I know that's a little bit annoying because it's such a long decimal, but really your calculator will do this part for you. So 20,000 divided by, you can just scroll up, hit enter, it'll copy it over, and there you go. So you have to deposit $12,764.49 to have $20,000 in your account at the end of 9 years in this scenario. And we can do that same exact type of thing with our other equation. So if we look at number 7, it says how much money invested at an interest rate of 6.1% per year compounded continuously. That's how we need to use the PERT formula. Will amount to $6,000 after 14 years. So we don't know how much money we're starting with, but we're investing at 6.1%, so that's our rate. Divided by 100 gives us 0.061. Compounded continuously just means we're going to use that E. Ignore that little scribble I have. And we want it to amount to 6,000. So our A is going to need to be 6,000 after 14 years. So that'll be our T. So plugging all that in, we have 6,000. P, we don't know what we're starting with. E is just E. R is 0.061 and T is 14. So again, E 0.061 and 14 is just a number, so I'll throw that into my calculator. So I'll do second and then ln, that'll give me E. And I want 0.061 times 14. I have this random decimal 2 point something. So I can rewrite this 2.349024181. Then we're in the same scenario we were before, and so we'll divide both sides by this decimal. You don't really have to show this step if you don't want to. It's fine. I'm gonna know what you're doing, but for now, because it's only the second time you've seen this. Okay. So we'll have P equals, go to the calculator, we're gonna do 6,000 divided by, just scroll up, hit enter, and there you go, $2,554.25. All right, that is all for today. Let me know if you guys have any questions.